Welcome to the first video on functions and graphs at Higher. Today we're going to look at set notation and then on to domains and ranges of functions. Okay, so three things we want to take from that is be able to read and write groups of numbers given in set notation. And then the second two things, identify and communicate the domain and the range of a function. Okay, the first thing we'll do is just very briefly go through some set notation stuff, just ways to write groups of things, predominantly numbers in maths, but a way to write groups of things in terms of set notation. And the guys who have done computing will be kind of familiar with this already. Okay, so vocabulary. Here, if we've got a set of collection of objects, we can write it as a set just by having the 2, 3, 4 like this here with the curly brackets. An element is a member of a set, so 2 is an element of the set 2, 3, 4, and a subset is a set that is part of another one. Okay, so 2, 3 is a subset of the set 2, 3, 4. Okay, now it doesn't have to work with numbers. It could work like a collection of objects, could be a set of higher maths kids. An element could be one of you guys. It would be an element of that set. You would be an element of the set of higher maths kids. And a subset could be a class. Okay, a higher maths class is a subset of the kids that take higher maths across the school. Okay, so the notation, this E means that it's a member of that set. So 2 is a member of 2, 3, 4. 6 is not a member of 2, 3, 4. And then if you just got two curly brackets, that's the empty set. So the set of four-sided triangles would be 1. Okay, another one could be the set of first years taking higher maths. Okay, there's no first years taking higher maths, so that would be an empty set. Okay, you've already been working with sets in your time in maths, even when you right way back to when you first learnt about numbers, you learnt really about the natural numbers. Okay, so that's just, we are 1, 2, 3, 4, 5 and so on. That is your natural numbers. Whole numbers is the same, but with 0 added. Okay, so you can see there that your natural numbers are a subset of your whole numbers. Okay, because it's the same apart from the zeros being added. Integers are the same but with negatives. So again, natural numbers are a subset of whole numbers and whole numbers are a subset of integers. Rational numbers are all those numbers that can be written as a fraction. So all the integers plus halves, thirds, 2 sevens, and so on. And then real numbers are that set of rational numbers but with stuff, irrational numbers added as well, so pi and all your surds. Okay, so those are your sets of numbers. Integers is probably the one that you've worked with most often. Real numbers is what really we work with pretty much all the time in maths, or at least all the time in higher maths anyway. Okay, real numbers is basically just everything we can, going up to and not including complex stuff, which you look at in advanced higher. Okay, so just one example of set builder notation. If we are listing the numbers in the set L, where L is all the x's, where x is between -1 and 3, not inclusive, and they're in the integers. Okay, I want to take L and write it as a set. Okay, I want all the x's, all the numbers between -1 and 3 that are in the integers and don't include -1 and 3. Okay, so that would simply be, L would be the set 0, 1, and 2. Those are the integers between -1 and 3, non-inclusive. Okay, now what we're going to move on to is functions, and functions is something you guys have worked with a lot. Okay, even back to primary school when you worked with function machines, we had a wee function machine, you put a number in, you got an output out. Okay, now functions, I'm going to use a graphic here from HSN, which is a great website if you haven't used it already. Your function relates a load of things going into your function, a load of inputs, and then gives you answers coming out. So a function that we would have used quite a lot, or an example of a function that we could have used quite a lot in National 5, if you had f of x equal 2x plus 5, you have a lot of x's that go into that function. You can put pretty much anything in, and then it would give you a load of answers there. Okay, now the domain is all the possibilities that can go into that function. So there we can put anything in at all. So that domain would just be the real numbers there. Okay, the domain for that function f of x would be all of the real numbers. Anything can go in. Okay, similarly, anything can come out of that. Okay, that range there is all the numbers and all the things that can come out. So that would be the real numbers as well. Okay, so we've got two parts of functions: the stuff going in, which is called the domain, and the stuff coming out, which we call the range. Okay, now the domain, there may be some restrictions on it. There's some things that don't work, and you have to be able to define the stuff that will not work as part of a function. And there's two main categories in that, two main things you have to keep an eye on. Firstly, if you have fractions, Okay, if you've got a domain and you have a fraction, you know, if I look up here, looking at the most simple case, if you've got a function that's 7 divided by x, this will work for every single number apart from 1, and it will not work for 0. Like if you put 0 in the bottom of that function there, 7 divided by 0, it would be a math error in your calculator. It wouldn't get, no matter how many zeros you are, you're never ever going to get to 7. So we have to set up our domain, the numbers that can go in, to restrict it so that we don't put anything into our function that won't work. So here, f of x is 7 over x minus 2. We do not want the bottom to be 0, so we do not want x minus 2 to be 0, which means we do not want x to be 2. So if I was to do my domain and writing it properly in set notation, I'd say x can be anything in those real numbers, but x cannot be 2. Okay, so that would be the domain there. It can be anything at all, but it can't be 2. Same here, we do not want the bottom of that fraction to be 0. So x squared plus 2x minus 15 cannot be 0. A little bit more complicated, but we know what we're doing here. If we want to find stuff where it is 0, it's going to be exactly the same process. We're going to put it into brackets, x plus 5x minus 3. Those can't be 0, which means that x cannot be negative 5, and x cannot be 3. And that means our domain is x can be anything, but x cannot be minus 5 or 3. Okay, that's us putting our restrictions of the domain. So that's the first thing you have to be careful of there. The second thing is underneath a square root. You guys know that you can't take the square root of a negative number, or at least at this level, you can't take the square root of a negative number. Okay, so in here, my function, root of 3x plus 2, I need, for it to work in all the real numbers, I need 3x plus 2 to be greater than or equal to 0. Which means 3x has to be greater than minus 2, and that means x has to be greater than minus 2/3. So our domain is, well, x can be anything in the real numbers, but it has to be greater than or equal to minus 2/3. Otherwise, we are going to have a negative going under the square root, and it will not work in those real numbers. Okay, same thing here for part B. We need the x squared minus 5x minus 14 to be greater than or equal to 0. Okay, and to find out what those are, I need to solve my inequality. Okay, and again, just to solve my inequality, for going back to quadratics, I'm going to need a wee sketch. Okay, so I'm going to find my roots, going to do a little bit of working. Okay, if x squared minus 5x minus 14 is equal to 0, that means x minus 7x plus 2 is equal to 0, which means x is 7 and x is negative 2. Hold on, I'm just going to so I just buy myself a little bit more room. So that means in my quadratic, okay, it's a smiley face, so it's going to look like that, and its roots are going to be at minus 2 and 7. So if I want this to be above 0, I'm looking at this area here and this area here. Okay, so that, going back to my domain, that means x can be anything in the real numbers as long as x is less than or equal to negative 2. Okay, I apologize, I'm going to have to go on to the next line here. And x is greater than or equal to 7. Okay, so that's my set notation there for the domain. Okay, x can be anything, it has to be less than negative 2, and it has to be greater than 7. Okay, so in this part and in this part of the graph. Okay, but the two key things are, you're looking for the domain, that you want to make a statement of the domain, you're looking for two things. Okay, you want not to divide by 0, and you want the square root, underneath the square root, to be greater than or equal to 0. Okay, now lastly, the range. Okay, the range of values that can come out. Now there's two kind of typical things here as well, and it's stuff you've worked with already, all over the place. Okay, a function is defined by f of x is x squared. Identify the range of f of x. Okay, now that range is the range of values that can come out of that function. Okay, the outputs for that function. Now we know no matter what we put into this function, no matter what x is going to be, we're going to have it as a positive or 0 coming out. Okay, so our range is f of x is going to be in the real numbers. F of x has to be greater than or equal to 0. The numbers you get out, the answers you get out, has to be greater than or equal to 0. Okay, same here, if we get the function cos x, we know for our cos x, all the values have to be between 1 and minus 1. There's no way of putting something into cos x and getting a number bigger than 1 out or lower than minus 1 out. So for that one there, our range is fx can be anything as long as it's between minus 1 and 1. Inclusive, sorry. Less than or equal to. Okay, so that's our range for the cos x function as well. Obviously it'll be the same for the sin x. Okay, so going back to learning intention success criteria, we need to be able to read and write numbers, groups of numbers in set notation. We need to be able to identify and communicate the domain, looking at fractions and square roots, and then being able to identify and communicate the range. Okay, so just being able to work with a function and see actually what values are we going to get out of that function. Okay, apologies for the length of the video, but thanks for watching. Cheers.